Am I audible? Am I audible?
Yes, sir.
My screen share is visible. Screen share.
Yes, sir.
Fine. So today we shall discuss some more numerical problems, and these are the exercise problems. So let us not worry about the answers here. It may be right or it may be wrong. So let us do this problem and check whether the given answers are okay. Fine. So now here you have it is a rectangular plate or a square plate. Sorry, rectangular plate. So the width is 50 units and the height is 40 units here. So here four forces, I think one here 50 kilonewton, the other one 8 kilonewton, the other one is 28 kilonewton, the other one is 50 kilonewton acting on this plate, and each it is a square unit 10 millimeters by 10 millimeters or whatever may be the units, whether it may be centimeters or millimeters. Okay, let us find the magnitude, the direction, and also the position of the resultant, and also the x-intercept of the resultant. Now this is the given problem. Now first select the reference axis. So let us call this point as say A, this as B, and this as C, and this as D. So first select the reference axis x and y. Now here in this problem, these are the values theta 1. Theta 1 is the 50 kilonewton force is making an angle theta 1 with respect to x-axis, and I think this is theta 2, whatever may be, theta 1 or theta. Let us find the values of theta 1 and theta 2, and also this is theta 3. These three angles we have to find. Now let us call this as theta 1. So theta 1 is nothing but it is 40 by 40. That is 1. I think it is tan 45, 40 by 45 is 1. So I think it is 45 degree, correct? Theta 1 just work out. Tan inverse 1, it works out to be 45 degree, I think. Correct? Because this width is 40 and this height is also 40. So tan theta 1 is opposite by so how much it is? It is 45 degree, I hope. Is it correct? So let us call this as theta 1, okay? So take the calculator and just work out, please. How much it is? This angle, can you hear me? This angle theta 1. This opposite side is 40 and this adjacent side is also 40. So 40 by 40 is 1. So how much it is?
45.
45 degree. Okay, you call this as theta 1. So theta 1 works out to be 45. Now let us call this angle as theta 2. Okay, the 50 kilonewton force, it is making an angle theta 2. So this height opposite side is 10 plus 10 plus 10, 30. 30 divided by 10. That is 3. Tan inverse 3. Theta 2. Let us call this as theta 2. How much it is? Theta 1 is 45. Theta 2 is
1.2.
how much it is? Anyone? 20? That is
1.24.
7.
I cannot hear. Anyone can tell, please. So there will be echo if too many guys speak. Okay. How much it is? Theta 2?
71.56.
Okay, 71.56.
71.56.
Okay, fine. 71.56. Now theta 3, let us call this as theta 3. The 28 kilonewton force making an angle theta 3 with respect to x-axis. It is 1, 2, 3, 4, 4 by 1. So that is 1, 4. So tan inverse 4, theta 3. How much it is?
75.96.
Okay, so write down theta 1, theta 2. Theta 1 happens to be 45. Theta 2 is 71 point something, 75 point something, or theta 3. Whatever the values you get, you write theta 1, theta 2, theta 3. Now, so let us find sigma f of x. Sigma f of x, the components which are horizontal to parallel to our x-axis. So 50, you can see here 50. Sigma f of x is 50 plus 28, 28 cos 45, 28 cos 45. Next, plus 50 cos theta 2, whatever the value that you got, theta 2, 50 cos theta 2. Next, 28 cos theta 3. Okay, sigma f of x will be 50 plus 28 cos 45 plus 50 cos theta 2 plus 28 cos theta 3. So whatever the value you get, just you write down. Okay, then find sigma f of x. It will be a positive only because all the forces are in the first quadrant only. Sigma f of x will be positive only. So anyone can tell me the answer, sigma f of x? So 50 plus 28 cos 45 plus 50 cos theta 2 plus 28 cos theta 3. What is the sum of sigma f of x? Has done it.
$92.40 Newton.
92.40 Newton. It is kilonewton. Just you can see the units here. It is kilonewton, not Newton. Okay. How much it is total?
92.40 kilonewton.
Okay, 92.40 kilonewton. So next, sigma f of y. Sigma f of y. So now, if you resolve this force, its y component will be 28 sine 45. 28 sine 45 minus 25. You can see here, you have a force here acting in the downward direction. So sigma f of y will be plus 28 sine 45 minus 25 plus 50 sine theta 2, whatever the value you got, 50 sine theta 2 plus 28 sine theta 3. So sigma f of y will be 28 sine 45 minus 25 plus 50 sine theta 2 plus 28 sine theta 3. I think we will get a positive value, I hope. So sigma f of x is 92.40 kilonewton and sigma f of y, just tell me the value, how much you got. So later on, let us check with the resultant value, whether it is correct or not.
$90.73 kilonewton.
90.73 kilonewton. Okay, fine. Now you got sigma f of x and sigma f of y. Now you use that equation, r is equal to square root of sigma f.
So
Huh? Pardon? Tell me.
69.36, so 69.395 kilonewton.
A sigma f of x is 92.40. Is it correct?
Yes, sir.
And sigma f of y?
69.395 kilonewton.
Okay. Now you find the resultant value. R is equal to square root of sigma. How much it is?
115.56 kilonewton.
You can see here it is correct. 115 point. So the sigma resultant value is correct. 115.563 kilonewton. So be careful about writing the units. You just have to be very careful whether it is in Newton or kilonewton. You have to write the appropriate units. Okay. Now we got the resultant value as 115.563 kilonewton. Okay, fine. Now theta, that is alpha or theta, the angle of the resultant, tan inverse sigma f of y by sigma f of x. So just check whether the value of theta or alpha is 36.90. So theta is tan inverse sigma f of y by sigma f of x. Is it correct? How much it is?
36.90.
Okay, it is also correct here. The answer 36.90 is correct. Now we got the magnitude of the resultant as well as the direction of the resultant. Now let us find the position of the resultant. That is d is equal to how much it is. So we have the basic equation r into d. That is the moment of the resultant. We'll be using the Varigno's theorem concept. R into d is equal to sigma. We can call this point as sigma A. Correct? Sigma MA, the moment of all the forces with respect to this point. Now let us start from one by one. Now this force is 28 kilonewton force is acting at point A itself. It's a concurrent force system. Now its horizontal component is 28 cos 45 acting like this, for which the moment is 0. And for the vertical component, it is acting along y-axis. You can see here, it is acting along y-axis. Hence the perpendicular distance is 0 for this 28 kilonewton force, because the x component is acting along the line AD and the y component is acting along the line y-axis. It is acting along y-axis, hence the perpendicular distance 0. So sigma MA is equal to, now you have a 50 kilonewton force, it is acting like this, correct, in this direction. And the perpendicular height is 30, correct, from this point to this point. So it creates a clockwise movement. So 50 into 30, it is 1500. 1500. Next. This is, we can call this as 50 kilonewton force, 50 kilonewton force. Now its x component is 50 cos theta to theta 2. So it is also acting along line AD, along x-axis, since the perpendicular distance for this horizontal component of this force is 0. But the vertical component is acting like this. It is 50 sine theta 2, 50 sine theta 2. Now it is acting in this direction, upward direction. And if you consider the moment of this vertical component of this 50 kilonewton, that is 50 sine theta 2. So it creates an anti-clockwise movement with respect to this point. And this is the direction of the force, 50 sine theta 2. And the perpendicular distance is this one, 40. So sigma MA is equal to 50 into 30 minus, okay, before that we have one more force here, 25 kilometer. So if you rewrite the equation, sigma MA is equal to 50 into 30 plus, so this 25 kilonewton force is also creating a clockwise movement about this point, and the perpendicular distance is 30. So sigma MA is equal to 50 into 30 plus 25 into 30 minus 15 sine theta 2 into 40. So it creates an anti-clockwise movement. And again for this 28 kilonewton force, its x component is 28 cos theta 3. It is in line with x-axis, so perpendicular distance is 0. But the vertical component 28 sine theta 3. So it also creates an anti-clockwise movement with respect to point A. So hence, the sum of the moments of all the forces with respect to point A, that is sigma ME is equal to 50 into 30, 25 into plus 25 into 30 minus 50 sine theta 2 into 40 minus 28 sine theta 3 into 40. So tell me sigma ME. Anyone is having any doubts with regard to finding out the moments? So tell me what is sigma ME. Once again, I will repeat, sigma ME will be equal to 50 into 30 plus 25 into 30 minus 50 sine theta 2 into 40 minus 28 sine theta 3 into 40. So tell me the value in kilonewton meter, that is the sum of moments. How much it is? Anyone else done it? Mr. Varun, LG, are you there? So all of you, please do the calculations so that you will become perfect in calculation. How much it is? Total sigma ME? So Hari Kashyap, Sri Hari Kashyap, are you there? Am I audible or not? Sri Hari Kashyap, are you there? Basuraj or Daniga?
Yes, sir.
How much is the answer? Have you done it? ಅರ್ಥ ಆಗ್ತಾ ಇದೆಯಾ?
Doing, sir.
Okay, tell me the value of sigma ME. Anyone? So you have to practice these calculations at home. Pick up any problem from the textbook and change the numerical values and try to do the problem. Not necessarily the same units, the same numericals you have to follow. You can change. So we got the resultant value as 115.563 kilonewton and theta is also same. So if you get sigma MA, how much it is? Anyone? In kilonewton meter. Vaishnavi MR. Vaishnavi MR, are you there? Ananya S. Nayak.
Yes, sir.
How much you got? And you got the answer? Sigma MA, anyone?
Yes, sir.
How much? Tell me. How much it is?
Sir, is that minus 50 sine theta 2 into 40 or 30?
It is 40. Because see here, the origin is here, correct? Both the forces are originating from this point. It is not 50 because you see the from where it has originated from this point, no? 50 and 28. So this distance you have to consider 40. Suppose if it would have been here, then it's different. Okay. This total width is 50. So since it is acting at this point, right? 28 and this one 50. So it is 40. How much you got? Anyone? So sigma MA is equal to 50 into 30 plus 25 into 30 minus 50 into 50 sine 45 into 40. 50 sine theta to whatever the value theta 2 you got. 50 sine theta 2 into 40. Again minus 28 sine theta 3 into 40. And this is negative. Sorry, this is 0 because it is acting at point A itself. Its vertical component is along y-axis and horizontal component is along x-axis. Anyone has done it? Calculation? Rajesh Kumar?
So minus 733.85 Newton meter.
Kilonewton meter. Minus
Yes,
7.
sir. Yes, sir.
Minus 7. Minus 7.
733.
Is it minus? Yeah, hello, tell me. Is it minus
So
total?
minus 7.
Okay. 7. So tell me how much it is. Is it plus or minus? Sigma MA.
So I got minus 733.85 kilonewton meter.
This is 15 to 30 is 1500. And this is
Yes,
again
sir.
25 into 30 is I think 750.
750.
Correct. Okay. Next 50 sine theta 2. What is theta 2 value you got it as?
71.56.
So 50 sine 71.56 into minus, it is minus 40, correct? Into 40 minus. Again 28 sine theta 3. Theta 3, how much you got?
$75.96.
Oh, okay. So 28 sine 73.96 minus 28 sine 73.96 into 40. So you get negative value or positive? Total.
Yes, sir. Negative, but sir, your voice is not up to clear, sir.
My voice is not audible. So you could have told
No,
me.
sir, it's breaking.
No, there is some unstable internet connection. Okay. Now I think it's okay. Okay. Anyway, now it is okay. Am I audible clearly?
Yes, yes, sir.
So anyway, you got sigma f of x and sigma f of y. Thereby, you calculated the magnitude of the resultant. We got the correct value. Theta also we got it as 36.90. But only thing is when you find the moment of all the forces, sigma MA. So this distance, we have to calculate the distance d. So R into d is equal to sigma MA. So d is equal to sigma MA divided by the resultant value. You will get it as whatever the value you get. But since you said the total moment is negative, correct? The sum of moments is negative, and sigma f of x is positive and f of y is positive. Hence, the resultant lies in the first quadrant only. And the angle made by the resultant with respect to horizontal axis is 36.90. So then you can find the value of D. So D is nothing but sigma MA divided by the resultant value. Check the value of D, how much it is. Are you getting the
6.350 meters.
Okay, it is also, you can see it is okay. Yeah, correct. Then you can find the value of x-intercept. So x-intercept is nothing but sigma MA divided by sigma f of y. So x-intercept value will be sigma MA divided by sigma f of y. Just check whether you get 10.576. Okay, almost 3 answers we got it correct.
10.574.
574 or 576. Okay. Anyway, so now I think we have understood the concept in a better way. Okay, next, last class we have discussed this problem, I hope. That is the dam structure. So we have to make the stability analysis, whether the resultant cuts the 1/3 base or 2/3 base. So we got it as 6 point something somewhere here. Okay, now the last problem under coplanar non-concurrent force system. Now here, forces acting on 1 meter length of a dam are shown in figure. So there is some network connection, unstable. Okay, forces acting on 1 meter length of dam are shown in figure. Neglecting the weight of the dam, determine the resultant force acting on the dam. Find the point of intersection of the resultant with the base of the dam. Now this is the given figure. Now here you have a dam structure and the forces are acting at different locations. Now let us call this point as A. Now let us call this point as B, point C, point D, point E. Okay. And these are the dimensions have been given here. Now first select the reference axis X and Y about point A. Okay. Now we have to find, once you select the reference axis, the next step is you have to find sigma f of x, the horizontal forces acting. So now sigma f of x. Now here in this given problem, so this angle is 60, correct? This angle is 60. So let us call this point as D. And the angle made by this slope line with respect to the horizontal is 60. If this angle is 60, obviously this angle is also 60 degree, correct? This angle is also 60 degree, correct? Now, here you have a force acting at this point. I think at a distance of 1.25 meter from point E. So here you have a force acting and this angle is right angle. So this is 90 degree. It is acting at this point. And this force, the line of action of this force with this inclined line is 90 degree. Now this angle is 60 and obviously this angle is also 60. And if I draw a line over here, horizontal line here, this angle is also 60. If I draw a line which is parallel to x-axis, so if this is 60, this angle is also 60. And if I draw a line over here, this angle will be 60 and the remaining this angle. So this 30 kilonewton force is making an angle 30 degree with respect to horizontal. Because if I draw a horizontal line over here, so this angle is 60 and this angle is 60. The remaining, because this whole angle is 90. So if I take out 60, so the angle made by this force with respect to horizontal axis is 30 degree. Now we shall find sigma f of x. So sigma f of x 50, correct? You have a horizontal force 50. And if I resolve this force, it is acting like this. And with the angle made by this force with respect to the horizontal is 30. So it is minus 30 cos 30, because this whole angle is 90 degree. And if I draw a line over here, so this angle will be 60, the remaining angle will be 30. So hence sigma f of x is 50 minus 30 cos 30. Correct? 50 minus 30 cos 30. So whatever the value you get, you write. How much you got? $50 minus 30 cos 30. ನನ್ನ ವಾಯ್ಸ್ ಕ್ಲಿಯರ್ ಇದೆಯಾ ಮತ್ತೆ ಬ್ರೇಕಪ್ ಇದೆಯಾ?
ಬ್ರೇಕ್ ಆಗ್ತಿದೆ.
So there is some unstable internet connection. ಕೇಳ್ತಾನೆ ಇಲ್ವಾ ಏನು ನಾನು ಮಾತಾಡ್ತಾ ಇರೋದು? Okay, anyway, so if that is the case, I will continue the class on Saturday. Saturday, I have my class at 10:45. So again, we shall discuss this problem on Saturday. Okay. So I'll be ending this session. So try to work out this problem. So then again, we shall discuss the same problem on Saturday morning. So I'll be ending this session. Thank you for attending the class. So have a nice day. Stay safe. Thank you.